So now we are starting our meeting. The next problem is problem example 6.2. So yesterday we have seen that okay, what is the Ampere's law in the magnetized material. So this is the problem of the Ampere's law in the magnetized material. So now if we look here, a long copper rod, this is the wire or rod, which is the long copper rod of radius r carries a uniform distribution of free current I is given in figure this. It means the current I is flowing in it. Here the current I is flowing in the upward direction, which we call it as a current is flowing along z axis, along k axis. Find the h inside and outside. We have to find h inside and outside. तो आपको पता है कि ये अगर मटेरियल है जिसमें करंट फ्लो हो रहा है तो एम्पियर्स लॉ आपको बता देता है कि द grip the wire in the hand, the thumb pointing the direction of the current and these curved fingers indicates the direction of the magnetic field. So it means we have yesterday seen that the h dot dl, this h dot dl is equal to the free current. So this dl अगर हम inside मालूम कर सकते हैं तो this is the circle which is the inside the copper wire and its radius we call it as its radius is s. So here the dl integral over dl gives you the circumference of that circle which is equal to 2 pi s. This is inside, and this if is the current, is the total current. So now how much current is flowing inside in this circle, which can be obtained the total current multiplied by the ratio of the area of this wire to the area of this total wire. Area of this circular wire whose distance, whose radius is s is equal to pi s square, and area of total wire is equal to pi r square. So if we multiply this ratio of the areas with the total current, this current gives you the current enclosed within this small circle, within this small circumference circle. So here this pi cancel, s square, one of the s is cancelled with the s. So the pi in cross multiplication going down. So this will be equal to if into s. If means current due to the free carriers, free charges, into s upon 2 pi r square. This is the h inside. Inside means the s is less than r. The distance where we measure the h value, h field is less than r, means inside. If we measure outside means s is greater than r. This is h dot dl is equal to if. If we measure outside, we will take a total current if. Because now grip the wire in the hand, the total current is inside here. So the current enclosed, if we measure outside, is the total current enclosed into this imaginary circular loop. अगर inside आप measure कर रहे हैं तो फिर current multiplied by the area of this imaginary imperial loop multiply ratio of the total imperial loop. So here this 2 pi r dl is integral over dl is equal to 2 pi s. This goes into the cross multiplication going down. So this h is equal to if upon 2 pi s. So here in this case outside the magnetization is 0. Outside magnetization is 0. So therefore the h, which is equal to b upon mu naught, which is equal to b, is equal to mu naught into h. Here there is another problem which we have अगर हमारे पास अब कोएक्सियल केबल है, आपको पता है कि कोएक्सियल केबल में दो सिलेंडर होते हैं, एक आउटर सिलेंडर, एक इनर सिलेंडर, और उसके दर बीच में जो होता है वो मटेरियल होता है, एंड वी कॉल दैट मटेरियल इज अ मैग्नेटाइज्ड मटेरियल. जैसे आप लोग कैपेसिटर्स पढ़ के आए हैं, सिलेंड्रिकल कैपेसिटर्स आपने पढ़ा है, दो किस्म के सिलेंड्रिकल लूप्स होते हैं मेटल के, एक आउटर दूसरा इनर, और उन दोनों के दरमियान जो मीडियम होता है व्हिच वी कॉल इट एज अ डाइलेक्ट्रिक मीडियम. इसी तरीके से हमारे पास कोएक्सियल केबल होती है, व्हिच कोएक्सियल केबल इज द सिलेंड्रिकल केबल व्हिच हैज टू सिलेंडर्स. One is the outer cylinder, we call its radius is B, and other is the inner cylinder, which we call it as its radius is A. It means the two cylinder, one cylinder is inside to the other cylinder, and the medium between these two cylinder is one of the medium which we call it as a magnetized medium. कोई भी मीडियम है जिसको हमने मैग्नेटाइज मीडियम कह दिया है कि it means when the magnetic field passes through that medium, the medium get magnetized, it dipoles aligns parallel or anti-parallel, it means it is magnetized medium. So now the problem of this coaxial cable here is, if we look here, this is the problem 6.16. A coaxial cable consists of the two very long cylindrical tubes. दो tubes हैं. One is inside, separated by a linear insulating material of the magnetic susceptibility chi of M. A current I flows down in the inner conductor. Inner conductor में current flow हो रहा है and returns along the outer one. कि inner से जा रहा है, outer cylinder से बाहर आ रहा है. In each, the current distributed itself uniformly over the surface given in figure. Find the magnetic field in the region between the tubes. As check, calculate the magnetization and the bound current and the current together. Of course, with the free current density, they are generated by the correct field. So now this is the figure. These are the two cylinders of the coaxial cable. One of the inner cylinder whose radius is A, other is the outer outer cylinder whose radius is B. The medium between these two cylinders is any magnetized medium or any insulating medium whose magnetization or susceptibility is equal to chi of M. Find the magnetic field between them. इन दोनों के दरमियान magnetic field क्या होगी? इसमें जो है, जो इनर सिलेंडर है उसमें करंट इस तरफ इनसाइड फ्लो हो रहा है और इस तरफ जाके फिर बाहर आउटर सिलेंडर से इस तरफ बाहर आ रहा है. तो एज अ चेक विथ व्हाट वी हैव टू फाइंड आउट, we have to find out the magnetic field. Find the magnetic field in the region between the tubes. जो ट्यूब्स के बीच में रीजन है जहां पे मैग्नेटिक ससेप्टेबिलिटी काई ऑफ एम है, वहां पे हमें मैग्नेटिक फील्ड मालूम करनी है क्या होगी बाय यूजिंग एम्पियर्स लॉ. अब आपको पता है कि एम्पियर्स लॉ जो है वो है बी डॉट डी एल इज इक्वल टू म्यू नॉट आई. ठीक. अब एच डॉट डी एल इज इक्वल टू आई इंटू एफ. This is the first equation is the Ampere's law in any medium, and this H dot dl is equal to I of A is the Ampere's law in the magnetized medium. Clear? So अगर H dl जो है इसका जो हम circumference ले रहे हैं वो 2 pi s दे रहे हैं. It means this is the circumference of any Amperian loop, which is the imaginary loop whose let's say radius is s. And S is the distance from the center of the inner cylinder to the distance between the inner and outer cylinder. So here, which is equal to 2 pi s, which is the circumference, integral over dl gives you the circumference, which is equal to h, cross multiplication gives you if over 2 pi s. Here we have an equation b is equal to mu naught h 1 plus chi of m. So here the m is directly proportional to h. So m is equal to chi of m into h. So m is equal to chi of m. H is equal to here from this equation. I have just substituted the value from this equation into this equation, I over 2 pi s. So this is the magnetization. So now the magnetization is given. हमें मालूम क्या करना है? हमें B मालूम करना है. B उस सूरत में मालूम होगी कि जब हमारे पास सरफेस करंट भी हो बाउंड चार्जेस का और वॉल्यूम करंट भी हो बाउंड चार्जेस का. और सरफेस और बाउंड करंट किस पे डिपेंड करता है? मैग्नेटाइजेशन पे, क्योंकि बाउंड करंट इज द कर्ल ऑफ एम वॉल्यूम और सरफेस का जो है एम क्रॉस एन. तो अगर हमें मैग्नेटाइजेशन होगी तो हम मैग्नेटिक फील्ड निकाल सकेंगे. तो इस वजह से सबसे पहले हमें मालूम क्या करना है कि मैग्नेटाइजेशन क्या है. तो यहां पे आप ये देखें, हमने सबसे पहले ये जो इक्वेशन है ये हमने मालूम की है मैग्नेटाइजेशन. अब मैग्नेटाइजेशन से हमने क्या है कि J ऑफ B जो है वो कर्ल ऑफ M है. क्लियर? अब कर्ल ऑफ एम यहाँ पे देखें, ये सिलेंड्रिकल सिमेट्री है, ये क्या है, सिलेंडर है, दिस इज द सिलेंड्रिकल सिमेट्री। तो यहाँ पे हम इक्वेशन यूज कर रहे हैं कर्ल ऑफ एम इन द सिलेंडर, दिस क्लियर। अब दिस फर्स्ट टर्म इज अलोंग एस मींस रेडियल, दिस सेकंड टर्म इज अलोंग फाइव, दिस थर्ड टर्म इज अलोंग जेड। हमारे पास जो मैग्नेटाइजेशन है वो कहाँ किस तरफ है, अलोंग जेड एक्सिस। तो ये जो फर्स्ट और सेकंड टर्म्स हैं दिस गोज टू जीरो, ये फर्स्ट और सेकंड टर्म गोज टू जीरो। सो जे ऑफ बी इज इक्वल टू दिस टर्म 1/s d over ds is m phi. This is m phi which is equal to I upon 2 pi s, chi of m I upon 2 pi s, chi of m I upon 2 pi s. S cancel here, other terms is constant, so the derivative of this constant term is 0. So this 0 is multiplied with 1/s gives you the 0. So the volume current density of the bound charges is 0. So the volume current density of the bound charges is not contributing into the magnetization. This is clear now. Only the surface current densities will contribute into the magnetization. The second equation is the surface current density, which is equal to m cross n. M is equal to I upon 2 pi s, which we have given this in this equation. Yeah, I upon 2 pi s into z, because it is along z axis. So kb is equal to chi of m if 2 pi s is equal to a, means at the surface of the inner cylinder, which is equal to this. At the surface of the outer cylinder s is equal to b, means this is in between. इन बिटवीन क्या होता है कि ये दो सिलेंडर है, एक है इनर सिलेंडर का सरफेस, दूसरा आउटर सिलेंडर का सरफेस। तो इन दोनों के दरमियान जो मीडियम है, उस मीडियम की जो मैग्नेटिक ससेप्टेबिलिटी है वो काई ऑफ एम है। क्लियर। तो दिस इज द इक्वेशन of the surface charges at the surface of the inner cylinder, because S is equal to A, and this is the surface current density of the bound charges at a distance S is equal to B. So as a resultant, this is KB at S is equal to A, this is KB at S is equal to B. So the total current is current due to the free charges plus current due to the bound charges, because the free current is also flowing in it. So here current free charges plus bound current is equal to KB into DL, surface charge multiplied by DL. This gives you the current. So KB is equal to chi of m, here it is given. IF is equal to 2 pi 8 multiplied by DL. DL is equal to 2 pi. This will cancel out. So the equation is equal to IF chi of m. IF is a common. So this is 1 plus chi of m. So that this is the total current. It means which is due to the free charge carriers plus due to the bound charges density. So this bound current is because of the surface contribution. Volume contribution is 0. So here now Ampere's law is B dot dl is equal to mu naught I. B is equal to dl is equal to 2 pi r. 2 pi r goes down, which is equal to 2 pi s, and I is equal to this. This is the I. Clear? So just substitute value I plus chi of m, 1 plus chi of m into I of f. So this is the magnetic field inside or in between the inner radius, inner cylinder and outer cylinder, which is from distance A to distance B. So this is the magnetic field. So here this is the magnetic field between this. तो यहाँ पे ये प्रॉब्लम नंबर 6.17 है, ये सॉल्व किया हुआ है, इसको भी आप देख लीजिएगा। ये इसके सॉल्यूशंस मैं आपको दे देता हूँ।